morning, everybody, and welcome. This is for a change. This is an actual focused tech talk on an actual topic. So we will get straight into it. We are focusing on what we're going to have a look at are the requirements surrounding pipe support brackets. How to support pipes in such a way that you will be it will pass an audit, for example, or for basically to be compliant. Now, if I can say straight off the bat that, and I think pretty much all auditors out there would agree with me that bracketing the pipe support is something that is probably most often mentioned on a failure on a COC on an audit. So we just don't get it right, and I include myself in everything. I'm saying we on purpose, because if you look at the standards, they are actually quite demanding. They want you to use plenty of brackets at very short intervals and so on. And what we tend to do is get in a rushed state, and we overlook what the requirements are. So it's vitally important that we understand what the standards say. And they say a few things about bracketing. This particular, or this I'm going to start with drainage pipes, and then we're going to move on to water pipes, because drainage pipes and waste pipes are just as important when it comes to bracketing, the support about it, and for all the same reasons, and some of the reasons even better than water pipes. Okay, what does SANS 10252/2 say about brackets on drainage pipes? It says that if you are using a type of pipe that requires protection from atmospheric corrosion, in other words, think about a metallic pipe such as, it wouldn't be that common copper, it wouldn't be that common galvanized, but certainly cast iron would be reasonably common. So if that requires protection against atmospheric corrosion, you need 30mm clearance all round. That already speaks to you about the type of bracket that you're allowed to use when you run in an external stack, for example, down the side of a building, and you have to protect this thing because you've got to get to the back of it to be able to paint it. Fixings are to be built in, nailed, or screwed. What it doesn't say there is that it needs to be screwed, nailed, or built into the structure of the building, and it says that in the water pipe section, but also in the drain pipe section. In other words, you can't strap it or bolt it or nail it to another pipe. That doesn't constitute a proper bracket. What it also says about vertical stacks, at the very least in a multi-story dwelling or multi-story building, at least one support per story. I cannot see a situation where you won't have at least one support per story. And then it says at least 2 supports between any joints. Now this thing, that little line there, has caught all of us out in the past. I can tell you straight away that if you've got an underslung situation, or if you've got a vertical installation on a stack, what we tend to do as installers, we tend to mark out our brackets in intervals, a meter or meter 1.2 or whatever your choice of interval is, and we just go ahead and do that, ignoring that between any 2 joints we need 2 supports. So very often we land up with 1 support between 2 joints, and it also says here adjacent to joints. So now, just in those last 2 lines, I think that's probably the most pertinent two points in this little section that will affect us every day as installers. The fact that if you go to a building site and have a run of sewer line vertically or underslung or whatever, and you simply preempt the positions of the brackets, and you strike a line, you mark out every 1 meter or 1.5 meters or whatever your thing is, and that's where your brackets are. You are not taking into account these 2 little guys here. At least 2 supports between 2 joints and adjacent to joints. So what is that telling us? It is telling us that we need to consciously design the placement of the brackets. Not so. We need to know what the layout is going to look like, and we need to place the brackets according to the layout. Some examples you'll see, most of this presentation is going to be pictures of both good and bad installations. We'll have a look in a couple of slides as to the maximum spacing requirements for brackets for various pipes, but I can tell you that there's not a single bracket in that frame, and for obvious reasons that's not going to be sufficient, both from a waste and sewer perspective as well as a water perspective. Right, continuing with drainage. The supports must be strong enough for the pipe's contents and the pipe itself, as well as shock loads. What do we mean by shock loads? I mean at the foot of a vertical section of drain where it changes direction and becomes horizontal. At some point, you're going to be experiencing shock loads there where you've flushed a toilet or two, whether it's 1, 2, 5, 10 stories up, it makes no difference. When the water hits the bottom of that foot or the foot of the vertical drain, there's a shock load attached to it. And that bend, that change of direction, which by the way is supposed to be a slow bend in most cases, will be experiencing loads greater than the total content of the pipe if it were full, plus the pipe itself. So it must be able to be strong enough to accommodate those shock loads. It must be appropriate to the pipe material, and they do give us guidelines here, the standards. I've left out the copper and the fiber pipes because that's really uncommon. But cast iron pipes, they give you 3 options for bracketing or supports there. They say it must be cast iron, malleable iron, or stainless steel. Plastic pipes require metal or plastic, but also it says, it continues to say, if you're using plastic pipes vertically on multi-story buildings, then you require metal holder bats for fire resistance purposes. Now, how many of us knew that? So even though you're using PVC pipes to go vertically up a stack, or whether it's in a duct or if it's external, if it's a multi-story vertical stack installation, you shall use metal brackets. Okay. So here are 2 tables. These are tables that are in SANS 10252/2, and they give us maximum distances between supports for various situations. I'm not going to go through everything, but what you can see here, if I just click, the PVC requirements. So you see at the bottom, the top row there is less than 50. In other words, a 40 mil PVC pipe. If it's vertical, you need supports every 1.5 meters. And if it's horizontal, every 600 meters. Anything equal to or above 50, which means pretty much all, it should be all external stack work, including waste pipes, because they should all be 50 anyway. Vertical is 1.8 and horizontal is 1 meter. So that's quite an easy, nice round number to remember. 1 meter is pretty much the minimum requirement between brackets centers. Then you go on to polyethylene pipes. Now these are the pipes that are typically melted together, right? We're all familiar with them. Not going to go into the debate as to the correct or incorrectness of the system, but we just go, what does it say about polyethylene? It's very specific here at the bottom where I've highlighted. It says the pipe supports provided by the manufacturer for this particular system should always be used. So it says to us that particular system's pipe supports must be used. You can't use the ones that you got stashed in your cupboard or anything like that. It's got to be specific to the system. It continues to say you need to change the maximum spacing of these supports according to the expected temperatures in the pipes. So you must bring those supports closer if you are expecting temperatures of about 20 degrees. And you need continuous support. Listen to that, continuous support. In other words, not intervals, like continuous support that carry for pipes that carry liquids above temperatures of 40. So just take note of that for those of you that use polyethylene piping systems. That's quite an often overlooked thing. As I say, there's a couple of examples, some good, some bad. Here's some good ones. At a glance, you could probably nitpick and say, there's a maybe there's a bracket missing there, and so on. If you really stick to the letter of the law, but all in all, notwithstanding the design of it, not going to comment on that, but the bracketing looks pretty solid. So does that over there, and that's what you like to see. Everything's straight, everything's lined up. You can see that it's got a proper fall, etc. Here's another one. Not so lekker. Okay, not so lekker. There are a couple of problems here. I'm not going to talk to the type of pipe or anything, but what happened to support between every two, or two supports between every two joints? What happened to supports adjacent to joints, which means next to? So here they should have had a bracket there and a bracket there. There should have been a bracket there and a bracket there, etc. So this is an option that's not so lekker, and you can see what's going to happen here. This is a pivot point. This is here where my little pointer is at the moment. That's a pivot point. Yes, I know this is fixed on the left-hand side, but at some point, this whole section over here has got movement in it. It's able to move. So there's a nice seesaw. Here's a nice seesaw because, okay, there's a fix and there's a fix, but you've got flex here, 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 and here. This is all flexible stuff. So you can move that around and eventually it could become misaligned, okay? Stuff like this, no brackets, nil. No support, not going to fulfill what we're trying to achieve. No brackets, again, where's that 1 meter? Type of pipe is incorrect, but we're not going to go there. There's a waste pipe over there, which has got no brackets whatsoever. So nothing to support it. Somebody's going to come along there, hang a coat hanger on there, and it's going to deflect that pipe. All right, water pipes. So what does a SANS 10252/1 this time say about water pipes? If you need to provide movement for pipes, for expansion and contraction, the following must be adhered to. I'm just going to click through it. There must be sufficient space for that movement of the pipe. There must be sufficient length of tubing around the bend and branch. There must be an offset or a loop to accommodate the movement. And hot water pipes longer than 18 meters must automatically be installed to allow for expansion. I'm not going to spend too much time there. This is not something that we spend too much time designing. This is for quite large installations where you need to actively make provision for movement in pipes, although we must expect pipes to move to a certain extent. But you can see there, for example, a hot water pipe starts needing that sort of provision at 18 meters in length, and they're talking about straight length. So that's usually bigger work, okay? Think about the purpose of holder bats. Why do we have holder bats? And we'll talk about that in a minute. But this kind of thing, ladies and gentlemen, is just not acceptable. The total lack of support, total lack of proper design. If I were to repeat myself, this is one of the most often or most common failures we come across from an auditing perspective is lack of bracketry or incorrect bracketry. 10252/1 continues to say noise and water hammer to be kept to a minimum. This is them telling you what you're trying to achieve. Well, noise and water hammer trying to be kept or must be kept to a minimum. The holder bats or brackets or fasteners must be attached to the building structure. Again, not to another pipe, not to a piece of conduit, to the building structure. Appropriate material and type for the pipe. They must be able to withstand the expected loads. They must be corrosion resistant. Type for the pipe. Think about dissimilar metals. Think about TP discharge pipes that can experience 18, 90 degrees C, and you've got a little plastic clip that'll melt at 40 degrees C or deform at 40 degrees C. Is that appropriate for the type of pipe? No. Able to withstand the expected loads. Very often we find pipe clips installed in such a way where the slightest breath of air is going to dislodge the pipe from the clip. Again, some examples of probably what you would want to see. This designer, the installer, has taken time to understand where his pipes are, where the fittings are, and he's put brackets in accordingly. Again, let's have a look at what the requirements are in the standards for the maximum spacing between pipes. And there's two tables, one for metallic pipes on the left-hand side here, table 21. And this, so you can just read, if you use different pipes, fine, but let's talk about copper. And you'll see the size range here, the top line is 15 to 25 or equal to 25, less than or equal to 25. So that's 15 mil. That's half inch, 3/4 inch, and 1 inch piping are subject to these distances here. This is copper. Non-vertical, in other words, horizontal or flat, 1.6 meters. That's nice and wide. You don't have to worry too much about 100 holder bats. Vertically, 3 meters. Hello, that's a nice big span. You can probably make that less, but still, it doesn't place that amount of pressure on you when you're installing these things. But hang on a second. Let's go look at polyethylene or just read plastics. Less than 20, in other words, half-inch piping. Non-vertically, 300 millimeters. Vertically, 600 millimeters. Between 3/4 inch and 1 1/4 inch. 400 millimeters non-vertically, and vertically 800 millimeters. So even when you go into the bigger diameters of pipes, you still have to put holder bats more than 2 a meter. All right, now think of running those pipes across a range of trusses. You're not going to be able to put a bracket on every truss because it's not close enough together. So you have to add additional timber or route the pipes differently. So it's added costs and so on. And if you haven't done that, ladies and gentlemen, please understand that it is non-compliant. If it is audited, it will fail. And you will have to go back and rectify it. And it's what the standards require. So in a nutshell, and to wrap up, what are we trying to prevent with bracketing? What is the purpose of bracketing, of pipe fixing? What are we trying to prevent? Now, to put it in a nutshell, sedimentation or sediment buildup. Think about a pipe, even a water pipe, hot or cold, more so hot, that has got a big bow in it. Think about it having a big loop in it. Do you think sediment is not going to build up in that pipe? Well, I've got news for you, it will. Eventually, it's going to start building up in that pipe, and it's going to start blocking off and changing the characteristics of the flow. Yes, of course, we talk about sediment in waste pipes. That's obvious. But even in water pipes, for example, think of an open to atmosphere overflow pipe, such as a PRV that's constantly wet, okay, constantly attracting little particles of dust if it's got a belly close to its outlet. Over a couple of years, that dust is going to go and settle in that belly, and all of a sudden that thing's blocked. Think of a TP discharge pipe with a belly that a little animal decides to nest in, and I'm talking about a spider or something, and some sediment and dust particles get trapped in there. All of a sudden you've got a blockage in your TP discharge, and when it needs to go, it can't. So we're trying to prevent sediment. We're also trying to prevent noise, both in wastewater as well as water, clean water, potable water. We're trying to prevent movement, for obvious reasons. When you've got movement in pipes, you've got stress on joints, you've got, noise is a result of that. The pipes themselves become stressed, and for obvious reasons. It's almost too obvious to mention, but there it is, movement. And of course, we're trying to prevent damage of all descriptions, both mechanical damage, corrosive damage, and there's an example of corrosive damage with incorrect fixings. That is as a direct result of electrolysis, and so that's the kind of damage that must be included in that. Blockage, as I've said, ties up with sediment buildup. Sediment buildup can have negative impacts on flows, but it can eventually, as I say, lead to blockage of the pipe, whether it's a sewer or waste or an important pipe like a TP. So, couple of examples of good and not so good. Here's one that the pipe has been supported every, been supported every 200 or 300 mil, but it's been supported with cable ties to another pipe. Now, you know, there's all kinds of things wrong with that, and it hasn't been routed properly. Changes of direction haven't been kept to a minimum, etc., etc., etc. I mean, you get one glance at it and you can just shake your head and laugh at it. You know, this is what we're trying to prevent. This is exactly the purpose of holder bets. It's the purpose behind applying your mind to say, okay, where are my pipe runs going to be? They're going to be there. I'd like to see that there. I'd like to come off perpendicular here, there. I can go up. I'd need an offset there. Picture it, figure it out, design it, and then carry it out, should I say. These are a couple of examples of very, very nice installations. The guy has thought about it. He knows that he needs to put brackets at X intervals, and therefore he's installed additional pipework support to be able to accommodate that. Each pipe is supported independently, so it's doable, and that's it.